So yes, next we move on to the three very important terms: isotopes, isobars, and isotones, right? So all of you should know the definition of an isotope, right? So what is an isotope? Isotope is defined as the um, atoms of the same element, okay? Different atoms of the same element. So if it's the same element, they will have the same atomic number, right? Okay, same element, different atoms, they will have the same atomic number but different mass number. Okay, so okay, one second. Just a second, it got out of the window. Yeah. Okay. So what is an isotope? Atoms of same element having same atomic number but different mass number, right? So all of you should remember this example. Hydrogen, if you take, hydrogen has 3 isotopes, right? So we represent them as this way. We represent them. Okay, so these are the 3 isotopes of hydrogen. What are the names? First one is called as the protium. This is called as the deuterium. This is called as the tritium, right? So protium, deuterium, and tritium, these are the 3 isotopes of hydrogen, right? So you can see they have the same, this is what atomic number, right? So they have the same atomic number. Atomic number is 1. Mass numbers are different, right? This is mass number of 1, this is mass number of 2, this is mass number of 3, right? So number of protons will be how much? If I have to write P, number of protons is 1, 1, 1. Number of neutrons is how many neutrons in protium, right? So you, from the mass number, you subtract the atomic number, right? 1 minus 1 0, 2 minus 1 1, and 3 minus 1 2. These are the number of neutrons, right? This is your atomic number, and mass number is obvious. Mass number is 1, this is 2, and this is 3, right? So same thing has been shown here, right? And all of them have 1 electron. Okay, number of electron, all of them have 1, 1, 1, because number of electron is same as the number of protons, right? So 1 electron each, 1 proton each, neutron 0, 1, 2, mass number is 1, 2, 3, right? So all of you should know this information, right? So these are the 3 isotopes of hydrogen: protium, deuterium, and tritium, right? So like that, you will have more isotopes, right? Carbon has 2, same atomic number, different mass number, 12 and 13. Chlorine has also 2. Okay, 17 is atomic number, and this is the mass number, right? So same atomic number, different mass number, right? So for hydrogen, all of you should remember these 3, right? Now isotopes can be of two kinds, stable and unstable, right? There are some unstable isotopes which are known as the radioactive, which are radioactive. So they disintegrate naturally because they have extra neutrons. Because of the extra neutrons, those are known as radioisotopes. You should know a couple of examples, right? Uranium 235, this is the mass numbers, and cobalt 60, this is also the mass number of cobalt. So these are two examples of radioisotopes. So these are your unstable isotopes, right? So oxygen has two isotopes, right? 16, these are the mass numbers, okay? If it is written on the upside, this is the mass number. So atomic number is 8, mass numbers are 16 and 18, right? Right. So let's for oxygen. Okay, this you can draw. It's easy. Just you have to just find out the number of protons, right? Number of protons will be 8. Both will have 8 protons. This will have 8 neutrons. This will have 10 neutrons, right? 18 minus 8, and you can draw the structures like this. Next, we move on to isobars. Okay, what are isobars? You can see this example. Isobars, if you see closely, they have same mass number is same, right? 40, 40. But here atomic number is different, right? So same mass number, different atomic number, and these are the atoms of different elements. So isobars, these are the, remember, these are the atoms of different elements. Whereas isotopes are the atoms of same element. These are atoms of different elements. So if the elements are different, they will have different atomic number, right? Having different atomic number, but same mass number. Okay. So remember, these are atoms of different elements. Examples are argon and calcium, right? So both have same mass number, but different atomic number. This has 20, this has 80, right? So our focus is mass number same, right? But they have different atomic numbers, right? 18 and 20. So this is the example. Argon and calcium are the examples of isobars, right? So you can draw the structure. Basically, in the center, you write the number of protons and neutrons, and you write the number electronic configuration around that, right? So that's simple, right? So these are the isobars and isotopes. One trick has been given here to remember. Okay. So in isotopes, you have T, right? T, and in isobars, you have B, right? So T stands for top. So if the top value changes, right? If the bottom value remains same, top value changes, that is isotopes, right? And if the bottom value changes, it's an isobar, right? So that is the bottom value, right? So bottom value changes, right? So that means it's an isobar. Right? So bottom value has changed, it's an isobar. And if the top value has changed, right? Top value change, that means it's an isotope. It's a simple trick, but anyway, directly also you can remember. Isotopes have the same atomic number, different mass number. Isobars have the same mass number, different atomic number, right? Next, third term is isotones, right? So Isotones, basically one way to remember is it has N. Okay, isotones basically have same number of neutrons. There will be atoms of different elements. They will have different atomic number, different mass number, but same number of neutrons. So I'll just write it here. Isotones, right? So remember this N stands for neutrons. You can remember it this way. N stands for neutrons. So isotones have atoms of different elements